Right, next question. Okay, calculate number of molecules in 0.25 grams of hydrogen. Okay, number of molecules in 2.25 grams of hydrogen. Now we've got some data here that's given to us. We've got a relative forming mass of hydrogen, and that's diatomic. Come back to that a moment ago, H2. The relative form mass of that hydrogen diatomic molecule is 2. We're also given this Avogadro constant. The Avogadro constant is just the name that's given to a number, and that number is 6.02 times 10 to the 23. It's a very big number, and that confuses lots of people. I always say to classes, just think of it like a dozen. A dozen is 12, obviously, and a dozen is the name given to the number 12. Well, the Avogadro constant is the name given to this number here. So we've got 0.25 grams of hydrogen. Okay, so what we have to do first, we have to have learnt this equation. Moles, so we need to work out the number of moles, is mass divided by the mass of 1 mole, in this case the relative atomic mass. I'm just going to use the formula, the symbol AR, to mean relative atomic mass. So the mass is 0.25 grams, 0.25 grams. Actually, we're using the relative forming mass here, aren't we? So let's change that AR to be absolute. Let's be picky, MR. That's the mass of 1 mole, the mass of the formula, if you like, the mass of the formula mass there. So 0.25 divided by 2. Okay, so 0.25 divided by 2. So 0.25 divided by 2. So stick that into a calculator just to be sure we get the right answer. That's going to be an eighth, and we can make that into 0.125. So 0.125, 0.125. So we've got 0.125 a mole. Okay, so we want to know how many particles we have now. Let's just go back to the dozen for a moment. You know, if for example the question was how many eggs do you have if you have half a dozen? You know a dozen's 12, and half a dozen I'm sure you know is 6. But the maths we'll do for that would be the half times 12, and that's exactly the same maths we're going to do here. Yes, the number is bigger, but the maths is identical really. We've got a quarter of a mole, or a quarter of a dozen, so we're going to do, not a quarter, sorry, an eighth. We've got an eighth of a mole, or an eighth of a dozen if you like, so we're going to do 0.125 multiplied by the number. Now we had dozen a moment ago. When we don't have a dozen, we've got a mole, and the number for a mole, the Avogadro constant, is 6.02 times 10 to the 23, so we're simply just going to multiply those now. 6.02 times 10 to the 23. So that is our formula. The number of moles multiplied by the Avogadro constant. So, putting that into our calculator, we've got the 0.125 there already. So we're going to do multiplied by 6.02 times 10 to the 23. Now, we do need to put this in correctly, and a lot of students make mistakes with this, so let's just take this really carefully. We're going to press 6.02 to start with. 6.02. Now, do not press multiply. Lots of students press multiply here. That's wrong. Do not press this button. Okay, do not press that button. Instead, we're going to use this button down here. On some calculators, it's labelled EXP. On an iPhone, it's labelled EE, but you're not allowed an iPhone in exams, so that's an irrelevance. But it's just another reason why you should get a scientific calculator. This button here, times 10 to the x. Let's press that one, times 10 to the x. So that is now multiplied by 10, so we now need to put in 23. 2, 3, and then equals. So we've got 7.525 times 10 to the 22. 7.525 times 10 to the 22. Okay, now the next sting in the tail here is the question says to 2 significant figures. So 2 significant figures, 7.5. We're not going to round that up, okay, because this number after the 5 is less than a 5. So it's going to be 7.5 times 10 to the 22. There's our answer. Right, next page. Lithium has 2 naturally occurring isotopes, lithium-6 and lithium-7. Just the way these are written, some people think this is minus here. That's not a minus. Okay, that's the mass number of the 2 isotopes that make up lithium. So often on the periodic table, lithium would be written like this. Lithium-6, and lithium-7. There you go. So lithium is made of two naturally occurring isotopes. So two atoms of the same element, same number of protons, different number of neutrons. A sample of lithium contains 9.92% lithium-6 and 90.08% lithium-7. Calculate the relative atomic mass of lithium in this sample. Give the answer to 2 decimal places. Let's underline that because that's quite important. So calculate the relative atomic mass of lithium in this sample. So the relative atomic mass is the average mass of these two isotopes. Now, there's 90% of lithium-7, so the relative atomic mass of this average is going to be quite close to 7. My guess would be between 6 and 7, around about 6.9, because there's 90% of it. So I reckon the answer is going to be about 6.9. Let's have a look. Right, to do this, we need to have learned this formula. And this formula is percentage times mass. Now we put that in brackets because we have to work that out first. For every isotope. Now in this case there's two isotopes, lithium-6 and lithium-7. So we're going to need that brackets for two isotopes with an addition in between. We add them together. So plus percentage times mass divided by 100 because these are percents. So percentage times mass. 9.92% lithium-6. So let's do that first. 9.92 times 6. Bracket it up. Plus percentage times mass. Percentage times mass. 90.08 times 7. Bracket it up. Because they're in brackets, we have to work them out first. So let's do that. Let's do that first. So we've got, let's have a look at this. Calculator on. 9.92 times 6. 9.92 times 6 equals, press the equals, 59.52. So that bracket there has worked out to be 59.52 plus 90.08 times 7. So cancel that off now. 90.08. 90.08 times 7 equals. So that's going to be 630.56 plus 630.56. So that's worked that bracket out. Divide all that by 100 and equals. So we now need to add these two together and divide by 100. So we've got 59.52 plus 630.56, 630.56 equals divided by 100, divided by 100. 6.9008. So it's about 6.9. So pretty much bang on. We have to give the answer to 2 decimal places. So 2 decimal places. There's one, there's the second one. There's no number after that that's bigger than a 5, so that's going to stay as a 0. So 6.90, and there is our answer. Right. 2.24 grams of iron reacts with 0.96 grams of oxygen. Calculate the empirical formulae. Okay, empirical formulae is the simplest formulae, so it's a ratio of one element to the other. Okay, what we do with questions like this, we divide the bit of paper in half to roughly about halfway down. On one side, we write one element, which is iron, which is Fe, that's the formula Fe. On the other side, we're going to write the other element, oxygen. Okay, O. And then we need to write moles equals mass divided by relative atomic mass. AR is the symbol. And we're going to do that on both sides. Moles equals mass divided by relative atomic mass. So the mass of iron in the question, 2.24. Let's put that in straight away, 2.24. The relative atomic mass given in the question as well, there's iron, 56 divided by 56. Okay. Oxygen. The mass of oxygen in the question, 0.96. 0.96 divided by the relative atomic mass of oxygen, 16. 16, right. So we now need to work those two out, and that'll get us 2 out of 3 marks if this were an exam. So let's work those two out. What do we say? Let's do this one. 2.24 divided by 56. 2.24 divided by 56 equals 0.04. So let's write that in there. 0.04. Okay. Over here now, 0.96 divided by 16. 0.96 0.96 divided by 16 equals 0.06. So our empirical formulae to start with will be Fe 0.04, oxygen 0.06. Now that's not our empirical formula because we're going to import an empirical formula to the smallest possible whole number. In a lot of cases that will be 1. If we look here, 4 is not going to divide into 6. Okay, so we can't have 1 as our simplest number. So our simplest number is going to be bigger than 1. Right. So one way of doing this is to divide the 0.06 by the 0.04. We divide by the smallest number. 0.06 divided by 0.04. Okay. So 0.06 divided by 0.04 equals 1.5 equals 1.5. So that actually tells us the formula is going to be, so we take the big number and divide by the little number, the number would be Fe1 O 1.5. That's a bit closer to an empirical formula, but this is not a whole number. So what we need to do is just add that on again until we get to whole numbers. So if we take another Fe1 O 1.5 and add those together, we would have Fe2 O 1.5 plus 1.5 is 3. Okay, and that is our empirical formula. It's quite a difficult one to get from that. Now, a lot of people with a feel for maths can just straight away see 4 and 6. Well, let's simplify that to 2 and 3, and that's fine. If you can't see that, then this dividing technique is quite good. Personally, I can see that, so I don't need to do this. But a lot of people do like to divide by the smallest number. Whichever number's smallest, just divide it by that, and it will tell you it will give you an idea of the empirical formula straight away, and you can just add them up then until you get to the empirical formula. Right, test done. Everybody should get 100%. Remember, you only need to get 75% to get a grade 9, but we can all do far better than that. Okay, good luck.